Can you hear my voice? 이거 어떻게 보는 거야? 뭐야? 아, 아니
아이고,
이거 잠시만요. 왜 이거 수락을 해야 되지?
그 처음에 이 회의 그 예약했을 때 그런 식으로 설정해서 그런 걸걸?
아, 지금 화면은 잘 보여요?
토픽 리뷰.
제 화면이 어떻게 보이는지가 안 보이네.
지금 딱 그 슬라이드
그거만 보이는
PPT
거죠.
화면 지금 너 마우스 있는 거 보여 지금.
이런 거 어떻게 보여요?
그 슬라이드 코멘트 노트까지 같이 보여.
쉣.
다른 쪽을 다른 화면을 공유해야 될 거야.
아,
아니면 공유할 때 이렇게 잘 보인다. 이게 맞아.
잠시만요. 이거 단톡에도 올려야 되니까.
너무 부담되지 않게 좀 덜 집중해서 듣겠습니다. 대충
아, 보면
대충 듣겠습니다.
집중은 뭐 야매로 온다. 이거 잠시만요. 이거 어떻게 하는? 코호스트를 줄 수가 없구나. 화면 지금 잘 보이죠?
응.
알았어. 잠깐 몇 분이야? 57분 딱 좋아.
선재 얼굴 뭐야?
선재 얼굴 있어요? 나 안 보이는데?
아,
보여줘 위에. 아,
나 웃기네.
so I start to present my topic about the 2D object detection. So in computer vision, the in deep learning society, object detection is a very famous task and very old and very highly studied part. So today I talk about it briefly and how the researchers are going on and which is the main idea of the object detection. So I'm gonna talk about what is the object detection. As you can see the page, the left side is the semantic segmentation. That means that it classify each pixels to some classes, which classes is belong to. So the blue part is means sky and tree and cat and some grass. But the object detection is mainly usually most of the object detection is using box to propose which object is located. So as you can see the middle side of the image, the boxes covered each object, and each box can classify each object is belong to some class. So red box means the dog, and the green one also means the dog, and blue one is the cat. And the other task that say instant segmentation is more complicated problem than object detection. Very similar to semantic segmentation, it also has to propose each pixels that and each pixels propose which each pixel are belonging to some class and more easily. Semantic segmentation is only classify each pixels to some class, which classes. But instant segmentation is different. That if there are same class objects are several in one image, it has to propose differently between same class. Semantic segmentation propose it for example, the start one of the image, semantic segmentation only classify each dogs are just dog. They will not separate two dogs. But instance segmentation, they have to separate two dogs because it is different instance. So it is more complicated problem. But today I will talk about the object detection. So in deep learning research, the object detection is studied with mainly studied in two ways. It is a one-stage detector and two-stage detector. It is the overall scheme of the papers, and I will talk about briefly about these ones and the recent study of the object detection. So the first, it is very famous paper that it called RCNN. It is maybe the starting point of the object detection in deep learning. And so I will talk about it briefly. So there is one input image, and the input image has several objects in one image. So they use selective search algorithm to propose the region interest to classify which box is which class. I mean, selective search is doing some collected the pixels. So it divide one image to several patches using the images feature, color information or location information. As you can see this part, one image are divided into several patches, and based on the patches, they propose the box mainly. And then they cut it off the box and they warped the image to the fixed size. So, and then they put that warped image to the convolutional network to classify and regress the box. When they classify the box, they use support vector machine in this work. So it is the main contribution of this paper. And the next one is the FastR CNN. They also use same algorithm for region proposal. They also use the selective search to propose the box, and then they put into the convolutional network by using array pooling. It is different with RCNN that in RCNN, warping the image is make just the image patches to the fixed size, so reduce the size or make the bigger, not using deep learning methods, but in this case, they use array pooling that they just cut into fixed size grids. And then, for example, in this case, we need to make the feature size as the 3x3. But the original, the feature from the proposed box has 5x7 size. So they have to reduce the size to the 3x3. When doing this one, they cut into the grid, fixed grid, number of grid, and then they do the max pooling for each grid to make it feature size to 3x3. It is the main contribution of this paper. And second one is that after doing array pooling, they put into the fixed size of features to the fully connected layers, and then do the softmax to classify the box which object it is, and then also do a regression to make the box coordinates more accurate. The next one is the faster CNN. It's maybe the most famous research of object detection. First, they do not use the selective search algorithm to propose the region. They use they propose a region proposal network. They doing this by using anchor box. So the first step is they use the backbone network using convolutional layers, and it produced some feature maps. And there are some sliding windows to capture fixed size of the features of each part of the feature map. And from that features, they propose regression points and the score branch. That means that it first in here classification layer, it classify it is object or not, and the regression layer means how much the coordinates have to move to make the box accurately. What it means that basically they use fixed number anchor boxes, and in this paper they use 9 boxes for each anchor, and from this sliding window, each one sliding window captured from feature map, they think that we will propose 9 anchor box. So they have different ratio and different size for same sliding window features. And then each regression layer propose how much the curtain of the box should to be moved to make the box accurately. So for example, if the 9 anchor box is here, then 9 classification layer and 9 regression layers are existed, because they have to propose the score and the regression coordinates for each anchor boxes. And then they also from this region proposal network, they will propose the box proposed by RPN, and then they also use the same one with fast RCNN. That means outright pooling. So they cut off the features the part proposed by the region proposal network, and then they doing that features to outright pooling to make the feature size fixed size to put into the classification and the regression layer again. So in this classification layer, they only propose it is object or not. So it has only 2 label. It is class, true label, and false label. But the next one, after outright pooling, they classify each box are belonging to which class. It is the very famous one, and it is the main work for 2-stage object detection. So now I will talk about the 1-stage detector. The first one is YOLO, you look only once. It is very simple one that not using different with faster CNN, they don't use anchor box. Rather than using anchor box, they cut the image, maybe the features to the fixed size of grid. It seems like S by S grid cut into the images, and then for each grid, they put into these patches to the layers to propose the box and the class. So it don't have to array pooling. You don't have to 2-stage, and the number they have to calculate is very small, because only each patches are putting into the convolutional layers to propose the box and the classification. It can be done in parallel time, so it is very fast, but the accuracy is lower than fast RC in a 2-stage scheme, because YOLO, the first version of the YOLO, has many problems to overcome. So the next work is the SSD single shot multi-box detector. They think that the problem of the YOLO is they only use the one stage level, one level of features. It means that if you do convolution with some hyperparameter, it reduces the size of the features. Actually, you can also keep the resolution of the features with the previous layers, but most of the backbone detectors reduce the size of the feature. It has much semantic information, but it reduced the location information. So because it reduced the resolution of the image, it simply reduced the resolution. So what I mean that for example, the original image is 300 by 300. Then after the backbone network, the result of the feature is 7 by 7. Think about that, for example. Then it only has 7 by 7 resolution. So one pixel of that feature has very big size in the original image. So it is hard to capture the small objects with 7 by 7 features because it has too low resolution. So overcome that problem, they think that they should use the high resolution, but has lower information about semantic. They think that they have to use that features also. So they propose that SSD that use several layers from the backbone to propose the box and the classification. Uh, but feature pyramid networks has make it more accurate and make it better about more than SSD. In SSD, you can see this part of C. It is very similar with SSD. They pass the image to the convolutional layers step by step, and each layers they predict the box and the class. But uh, the the first and very how to say 그 앞부분을 뭐라 그래야 되지? Think about this image. The first feature map is only doing one convolution. This feature map has doing twice, and this feature map has third time, and then over and over. They will get more semantic information from doing convolution. But this first layer or second layer has too low information, low trained by convolutional network. So they think that this first or the second or anyway, the first stage feature maps layer has lower information to not enough to predict the box and classify the box. So they think that use both of them. How to use both of them? They think that this is top down and this is bottom up. I mean, they use twice two ways to predict the box. Uh, let's see this image. This image is more accurate. They doing pass the image to the composition layers to reduce the size of the image, and then they are doing back again. I mean, upsampling the feature maps to the before layer steps feature map size, and then they connect the same size features using skip connection, just adding. How they upsample this layer is just doing nearest neighboring. They copy each values to upsample to the higher resolution. And then they predict the box and the classification for each layers, and it has higher performance than before work. And this kind of feature pyramid network is used widely to the backbone network because it has it can utilize high resolution and low resolution, the strengths of both of them. The third one is the RetinaNet. I didn't show the network architecture because they use just backbone. It has almost same with the feature pyramid network. This paper proposed that the focal loss, what the focal loss means that they think that there are very critical class imbalance in training a data set in object detection. So more exactly, they think that the between positive object and the background object between both of them has very high imbalance. So so too many background objects are disturbing the training object for object detection. So they suggest to use not just using cross entropy laws like this one. They add the part of this one to address the problem of class imbalance. Here's the PET means uh, uh, the probability of the positive the object is here. Uh, Gamma is just hyperparameter, this one. So they use this loss and they get more lower loss by using this one. And this one is also the one stage detector. The first, they also use feature pyramid network in here, and it is very same scheme for one stage detector or recent all of them. They use feature pyramid network and propose each region proposed by each layer of the feature map. And first they most of the work before they use some kind of use coordinates like left top and right bottom coordinates. So what I mean to explain to show how to say to, 그러니까 그 박스를 표현하기 위해서 뭐라고 말해야 될지 모르. To show the box coordinates, they use left top coordinates and the right bottom coordinates, or center XY and then width and height value. But in this case, they predict the center and then I mean they don't predict the center, but they use the center from the given the fixed points for each pixel fixed feature map. It seems similar with this one, fixed grid, but they use fixed center points, and then they predict left, right, and top and bottom value. How long, how much size of the, how much the box size is. And then they not only doing this one, they also predict the centerness of this center points. Centerness means that this center point is it classify the center point is close to the ground truth box center or not. So the high centerness value means the point of this one is very close to the box center of the ground truth, and lower centerness points is it has far from the center of the ground truth. They propose this one, and it also brings some advantage in accuracy. So what I'm talking all of the works are based on or one stage or two stage schemes in here, but from this one it is a little bit different with one stage or two stage scheme. It's quite a totally different scheme with original object detection research. The ETR is utilizing the transformer encoder decoder to predict the box, but transformer is just not the main contribution of this work, because transformer is already proposed work in natural language processing part. But in this case, they changed the scheme of the object detection to set prediction. It is that basically before every research of object detection propose the box using region proposal or fixed grid of the features, and then they propose every size and ratio of the box and they regress that one, and then they use IOU to match with the ground truth and the train. And then they use also non-maximal suppression. That means the way how to remove boxes that is useless or overlapped, because they those works propose a lot of box for same objects, but each object has a little bit different coordinates and size, but though between them there are one most accurate box in there, so non-maximal suppression can remove the other boxes that less accurate than one. So but this work, they do not use non-maximal suppression to remove the box. Rather than non-maximal suppression, they use bipartite matching to match the proposed box to the ground truth. So they don't using non-maximal suppression to remove the proposed and propose the box. So how they match the predicted box and the ground truth seems like here. First, they predict the fixed number of n prediction, and then they add one more class that means no object. So if the box is predicted to no object, that means they don't have to train because it is not an object and truly proposed box. So they predict the n prediction by using transformer, and then they match it between ground truth and the predicted box, all of them using permutation. So then they calculate the cost followed by this. Um, to calculate the score and match, they also use the IOU to propose and score the ranking between ground truth and the prediction. 이건 좀 까먹었는데. So they also proposed Hungarian laws to match between bipartite matching, but I'm sorry for this one. I really forgot about the detail from this work, so I will explain later more detail. But the main idea and the most important thing is here they proposed they make the object detection task scheme totally different to make it set prediction different with before one. And the final paper, what I will talk about is that deformable D tier is totally same scheme with D tier, but quite different because the D tier has very big problem that they need a lot of epochs and times and computation to train the network. For example, one stage detector trained in one day in one single GPU. Maybe it is different with data set and the computational work, but DTR has over than 500 or maybe the 1,000 times to train the network, but so it takes about 1 week or more. But the former DTR addressed that problem by using some very similar with deformable convolution. So they don't do self-attention for every feature points. Rather than doing self-attention for every points of the feature map, they use sampling offsets. That means in this part, they only using this point to doing the self-attention in transformer. And then they train from this sampling offset, they train which point they should use to self-attention. So each head can train that, and then from that each head they doing self-attention. Then same with the D tier, but they has reduced size for self-attention. and they result the better score, their better accuracy, and in computational time and training time, they hardly get better performance because it takes only 50. They say they got the enough performance only training with 50 apples, while the DTR trains over than 500 times. So that is the main idea of this paper, and they reduce the time, reduce the computational time and the network very simply to train and very easily converge. So it is the last work what I'm proposing for this presentation. So thank you for listening, and if you have any question, please give me the question. I will answer about that. If so,
Thank you.
thank you.
Thank you.